Hello there, my name is Anthony Coleman, and today I'm doing my presentation video on linking people in videos with their names using code reference resolution. This is the introduction. Okay, this paper was written by Vinesh Ramanathan, Armand Julian, Percy Lang, and Lee Fei of Stanford University. And the purpose of this paper is to introduce a model that tackles person naming and code reference resolution jointly, allowing information to flow bi-directionality between text and video, and the use for this technology is correctly identifying people on television shows. Keywords. Here's some of the keywords that you should know and get yourself familiarized with. First is natural language processing, and this is an area of computer science and particularly artificial intelligence concerned with the interactions between computers and human quote natural languages, in particular how to program computers to process and analyze large amounts of natural language data. Person naming. Person naming is identifying the name from a fixed list of each person appearing in a TV video. Code reference resolution is the task of finding all expressions that refer to the same entity in the text. And if you see on the right here, you see two dual examples of one is one directional model on the left, the other one is bidirectional model on the right, and this is from the Big Bang Theory. The one right here on the left shows only one pronoun, one proper noun, I should say, one proper noun identifying the character Leonard. But on the right one is more detail and in depth. It has Leonard, then also the other that says he, which correctly identifies himself, and the other one is Howard, going into engineer, it referred to himself as the engineer. And this specifically is how the model should work for co-reference. It means everything that is, even if it's a pronoun, the proper noun, everything is being related back to them, and that's the person correctly each time. Here's a problem setup. The writers are given a set of video script pairs representing one TV episode. P is a set of P names / persons appearing in a cast list. T is a set of T human tracks extracted from the video, and this represents the video side of the experiments. For each track T that's an element of T, let YT be an element of P that denotes the person name assigned to track T. We also define a matrix Y that's an element of 0, 1, T by P, where YTP is equal to 1 if YT is equal to P. On the language side, each script is a sequence of scenes, and each scene is a sequence of dialogues, D, and descriptions, E. For descriptions, we extract a set M of M mentions corresponding to people. A mention is either a proper noun, e.g. Roland, a pronoun, e.g. he, or nominal, e.g. foreigner. For each mention M, which is an element of M, let ZM be an element of P, persons, assigned to mention M, and then define a matrix Z, which is an element of Z1 mentions by persons, where ZMP equals 1 if ZM equals P. The goal is to infer the person assignment matrix Y and Z given the crude alignment as well as features of the tracks and mentions. Okay, here we have an example that's here to the right that's actually taken from the text itself. And once again, I want to state the goal is to take all this information so we can assign it to a person P, to our set P, to each human track, which is like you see right here, the video, the snippet of the video itself is the human track, and which denoted by for each person that's represented in the picture is T1, T2, T3, T4 for each person. And Y1, Y2, Y3, and Y4 are the name assignments matched to the corresponding tracks themselves. Now after that, you see right beneath it, between the blue arrows and dotted blue boxes, the alignment between the tracks in the mentions themselves. And then from there you see at the very bottom we call descriptions, which is our descriptions, which is the dialogue themselves we get from the script, which is Roland arrives, he looks foreign, Ian waits as the foreigner rides up. Roland, of course, is the proper noun, he is the pronoun, Ian is another proper noun, and foreigner is a pronoun. And these are what they say for M is the mentions. So Z goes up into there, and then we connect the information to the name assignments in the human tracks. Right now we're describing the model that they're going to be using for this experiment. Here are the variables that we're going to be using, which is Y, Z, R, and A. The name assignment matrix for tracks Y is an element of 0, 1, T by P. Name assignment matrix for mentions Z is an element of 0, 1, M by P. The antecedent matrix R is an element of 0, 1, M by M, where RM prime indicates whether the mention M, i.e. he, refers to the M prime, e.g. Roland, based on the text and hence refer to the same person. In this case, M is called the antecedent of M. Next is the alignment matrix A, which is an element of 0, 1, T by M between tracks and mentions, where ATM indicates whether track T is aligned to mention M. Here's the model continued. Right now we have the cost function. The cost function C, which is C Y Z R A, is by definition equal to gamma T times C track Y plus gamma M times C mention Z R plus C line A Y Z, where gamma T and gamma M are hyperparameters governing the relative importance of each term. The three terms are as follows. C track Y is only based on video face recognition features. C mention ZR is only based on text features, using co-reference features to influence R, and thus the name assignment Z. C align AYZ is based on latent alignment A of the video, in which imposes a soft constraint on a relationship between Y and Z. The model continued. Regression-based clustering, one of the building blocks of this current model. An algorithm assigned with the task of assigning binary vector labels to each identifying point X, i.e. a standard image or pixel, everything we've been covering in computer vision so far, so each nearby point receives the same label. The model continued. C track Y is a cost function used for name assignments to tracks. C mention ZR is the cost function used for name assignments to mentions and co-reference resolutions. C align AYZ is the cost function used specifically for alignment between tracks and mentions. Okay, now we're on the experiments part of this video. The model was evaluated on the two tasks, name assignment to tracks and videos, and name assignments to mentions in the corresponding scripts. The data set they used were 19 random episodes from 10 different TV shows. They say that the data set is split into a development of 14 episodes and a test set of 5 episodes. Experiments to evaluate the name assignment task in videos, they manually annotated the names of human tracks from 3 episodes of the development set and all 5 episodes to the test set. To evaluate the name assignments to mentions, they annotated the person names of the pronouns and nominal mentions in all episodes. Here are the results. These are the average precision results for name assignments to tracks videos for the researchers' models named R, BIDIR, compared to the other 6 state-of-the-art models. And as you can see on the right, that's where all the information that's tabled, all the information that's referenced. For the development set, it had the highest average precision for each episode and the highest mean average precision as well. For the test set, the researchers had the highest average precision for 3 out of 5 episodes and had the highest overall mean average precision. Name assignment dimensions were judged by accuracy, meaning percentage, the fraction of mentions to the correct person name. The researchers' model was used against standard conference resolution systems in several baselines. The researchers' model had the top results for both the development and test sets, 64.42% and 56%. In conclusion, the researchers were able to prove their bidirectional model for name linking is superior to a unidirectional model. It can conclusively outperform the other models. However, the accuracy is still far from perfect and more time is needed to perfect the technology.